Hello and welcome to Precalculus Lesson 6. In this video lecture, we're going to learn about equations involving rational expressions. We're also going to learn about equations involving radical expressions. And finally, we're going to look at equations that are quadratic in form. Let's go ahead and start with rational equations. A rational equation is an equation that contains at least one term that is a rational expression. The most efficient approach to solving rational equations entails clearing of all the denominators in the rational equation using the clever application of the multiplication property of equality and multiplying both sides of the rational equation by the LCD of all the denominators in the equation. So you're going to look at both sides. Make sure that all the denominators are in factored form, and then go ahead and form your LCD. Now, any solution arising from the solving of the denominator cleared equation that would make any of the denominators in the original equation 0 will be excluded, because it would, plugging it would make the original equation meaningless. So remember, every time you modify an equation, like by multiplying both sides by a given expression, or by squaring both sides, or any kind of modification, you really need to check your solutions at the end of your work, because you haven't quite solved the original equation directly. You've solved a modified version of the original equation. So it's always important to check your solutions at the end. Okay, let's go ahead and take a look at this problem. Notice that we have a simple equation involving rational expressions. We do notice that the denominators involved here are 3 and x minus 1. We have a 1 on the other side for a denominator, which isn't really going to contribute anything to our LCD. So the first thing we'll go ahead and do, we'll go ahead and decide our restrictions. What are the values of x that, even if they pop up as a solution, we should not accept. Notice that x equals 1 would make this denominator 0. So we want to make sure that x does not equal to 1. In other words, if that turns out to be the only proposed solution, we'll reject it and we'll say there is no solution. Otherwise, as long as the solution we get is anything other than 1, we should be okay. All right, so let's move on to finding the LCD. Now the LCD here is also simple. It's just going to be 3 times x minus 1. So now we're going to multiply the LCD on both sides of the equation, and we make sure that we distribute. So we have 3 times x minus 1 that we're going to multiply on the left side and also on the right side. And don't forget that on the left side there are 2 terms, so we need to distribute it, the 3 times x minus 1. So we end up with 3 times x minus 1 times the first fraction, 3x minus 1 over 3, minus 3 times x minus 1 times 2x over x minus 1 equals 3x times x minus 1. So now we carefully cross cancel everything that we can. We notice that in this first product here, we can cross cancel the 3's. In the second product here, we can go ahead and cross cancel the x minus 1's. And here there's no cross canceling. Now, always remember, you have to watch these videos very interactively and be fully engaged. So at any point, if you feel like, oh, I've got the rest of this, go ahead and stop the video and finish it on your own, and take it from there, and then you can come and see if your answers agree. So we have x minus 1 times 3x minus 1 minus 3 times 2x equals, here let's go ahead and distribute that, so that's 3x squared minus 3x. So on the left side, we'll go ahead and multiply this out, so we get 3x squared, and then minus x minus 3x, and then the last term will be plus 1, and then we have minus 6x, don't forget that part, equals 3x squared minus 3x. So we'll continue to simplify. You don't want to start moving things around in an equation until you've fully simplified both sides. So we have 3x squared minus 4x minus 6x. Let's go ahead and just combine them all at the same time. So we have negative x, negative 3x minus 6x. So that's 1, 4, 10. So negative minus 10x plus 1 equals 3x squared minus 3x, right? Now I notice there's no more simplification possible on the left side and no more simplification possible on the right side. So now we go ahead and consider what we can do to both sides. The first thing we notice is that we have the exact same term on both sides of an equation. And you know what that means? That means you can basically cross them out, since you can simply add the opposite to both sides. So, or just subtract 3x squared from both sides, right? So that part we don't need to worry about anymore. Those cancel out. And we go ahead and write down what's left. So we have negative 10x plus 1 equals negative 3x. So let's go ahead and move the negative 10x to the other side by adding 10x to both sides. So we end up with 1 equals 7x. Now we simply have to divide both sides by 7. So we end up with x equals 1/7. Now, the very first thing we need to do before any other kind of checking is to make sure that this passes the restriction test, right? Notice x should not be 1, and of course 1/7 is not 1. So we'll put a check R, meaning we check the restrictions and it's okay. So beyond that, you know, for a quick check, you can always plug in the 1/7. Now, in order to keep the length of our video at a reasonable level, I'll go ahead and just show you how you can quickly check that on a calculator. So we'll go ahead and type in 1/7 for x in this equation on the left side, and then we'll do the same on the right side. So notice here's a nice trick. Go ahead, when you see you have to input a fraction, go ahead and just put the fraction sign first, but then you'll have to go up to the top and get rid of anything that may have come up already. So make sure you get rid of that answer and go ahead and instead type in what you're going to type in, which is basically 3 times 1/7. Notice I'm typing it exactly as I see it. And then we want minus 1. Then we move down to the denominator and put a 3. Now I'm using a pen, but you can also do it with the arrows on your keyboard. Minus, again, I'm going to input a fraction, so I'll go ahead and just put the fraction line. That way it's ready for input on the top and the bottom. 2 times 1/7, right? And we'll move down below, and we're going to put 1/7 minus 1. and I'm going to hit enter. Just make sure, since you're transferring from one medium to another, make sure you've copied it correctly. So we have 3x. Remember, we're replacing x with 1/7 minus 1 over 3 minus 2 times 1/7 over 1/7 minus 1. All right, so we get that. Now we have to replace this side by, do the same substitution on this side. And of course, that's just 1/7, right? So once I put that in, then I notice that the left side gives me the exact same result as the right side. So we have done it correctly. So we can now confidently write down what our solution set is. So at this point, we say S equals the set. The solution set is the set containing 1/7. Remember, once you write a solution set, you don't put any variables or anything in here. You just put the numerical value of the solution. All right, so that's how we do that, and make sure you can handle that, and then we'll proceed. All right, so let's take a look at this problem now. The restricted value, the one we cannot accept, is going to be 2, right? Because that would make both of these denominators a 0, and therefore both of these fractions undefined. So the restriction here is that x should not be 2. Now we'll go ahead and proceed with finding the LCD. What's the LCD of both sides? It's just going to be x minus 2, right? So now we go ahead and we multiply both sides of the equation by the LCD, which is x minus 2. And on the right side, of course, we have 2 terms, so we have to remember to distribute, right? So on the left side, we have x minus 2 times x over x minus 2. And on the right side, we have x minus 2 times 2 over x minus 2 plus, don't forget that 2, even though it's by itself, it does need to be multiplied by the LCD, like that, okay? Now we go ahead and cross-cancel as much as we can, noting that here the x minus 2's will cancel out in the first term. And the first term on the right side, the x minus 2's cancel out as well. And that's all the cancellation we have available to us. So we end up with only x on the left side. And on the right side, from the first term, we're left with 2. And then plus 2 times x minus 2. So we have x equals 2 plus, now we're going to distribute the 2. Make sure you don't add those first. You know the order of operations tells you have to multiply before you add. So plus 2x, and then 2 times negative 2 is minus 4. So we need to keep going because we haven't simplified the right side fully yet. So we get 2x, and then 2 minus 4 gives us minus 2. So now we go ahead and move the x to the other side by subtracting x from both sides, and we'll go ahead and move the negative 2 to the other side by adding 2 to both sides. We can take care of both of those at the same time. So we have the x's canceling out over here, leaving us only 2. And on the right side, the 2's cancel out, the negative 2 and the positive 2, and we get 2x minus x, which is x. All right, so here's the only solution that we have come up with, and what happens? It fails our restriction check. It doesn't pass, right? So did not pass. So therefore, since the only potential solution ended up not being a solution, right? What do we have to say at this point? That there is no solution. The way you say that professionally is you say the solution set is empty. Remember, you can also write that just using braces and putting nothing inside the braces. That's also another way of indicating the empty set. And another name for it is the null set, N-U-L-L. So you can say the null set, the empty set. You can use this symbol, or you can use just braces with nothing inside. They all mean the same thing. The solution set is empty because there is no solution. All right, so please make sure you understand that, and we'll move on. All right, let's go ahead and try this one. Now, this is the first one we're looking at where we actually have to do a little bit of factoring first. Remember, before you decide what your restrictions are and find your LCD, before both of those actions, you need to make sure your denominators are fully factored out so that you can easily find out what values would make any of the denominators 0, as well as easily find the LCD. So let's go ahead and take care of that first. So that's the first thing we'll do. So the first denominator is simple. We can't factor anything, as is the second one, but the denominator on the other side, I'm just going to put the negative on this side. I notice that I can factor out an x, and that leaves me x minus 2. So the x squared minus 2x factors as x times x minus 2. So now we can see the problematic x values will be 0, right, and positive 2. So for our restrictions, we're going to say x should not equal to either 0 or 2. Okay, now how about the LCD? Well, the LCD is also, remember, to find the least common denominator, once you're in fully factored form and these have been simplified, meaning you don't have x times x or anything like that, then all you have to do is pick the highest power of each factor to come up with your LCD. The highest power of x that I see is just x itself, the first power. So that's going to be part of the LCD. And then I'm going to multiply that by the highest power of x minus 2, which happens to be 1 as well. So just like that. So there's your LCD. So now we're going to multiply that on both sides. So we get x times x minus 2 times 3x plus 2 over x minus 2 plus, don't forget the distributive property, so we have to multiply it by the 1 over x as well, as well as on the right side because of the multiplication property of equality. Okay, so now we multiplied both sides by the LCD, which we found to be x times x minus 2. Now we're going to cross cancel as much as we can. In this first term, right, we notice that we can cross cancel the x minus 2's. In the second term, we notice that we can cross cancel the x's. And in the third term on the right side, we notice that we can cancel both the x and the x minus 2. All right, so now we carefully go and see what's left behind. So we notice we have x times 3x plus 2 plus 1 times x minus 2, which is just x minus 2. We don't really need the parentheses anymore, equals, here these canceled out, so the only thing left is negative 2. So we have 3x squared, I'm just going to distribute the x now, plus 2x plus x minus 2. Let's go ahead and move the negative 2 to the other side, so it becomes plus 2 equals 0, right? So remember, once you go into a higher order equation above linear level, you have to move everything to one side and try to factor, right? It's different from how we handle linear equations. So now we have 3x squared. Now plus 2x plus x gives me plus 3x. And I notice that these two cancel out, equals 0, right? So I immediately notice I can divide both sides by 3 right away, get rid of the 3. So we get x squared plus x equals 0. Because remember, 0 divided by 3 is just 0 anyway. So now we can factor the x. That leaves us x plus 1 equals 0. And now we'll go ahead and apply the 0 factor property. So either x must be 0 or x plus 1 must be 0, which gives me x equals -1. All right, so now I have to do my restriction check on both of these. Now 0 fails. Remember, 0 is one of the values we cannot have because it would make this denominator as well as this one, because of the factorization, you can see 0, and therefore it would make both of these fractions undefined. So 0 is no good. This one fails the restriction check, but -1 is fine. It passes, right? So the only thing you may want to do at this point, if time permits, like let's say if you're in a test situation or whatever, you may want to plug it in and check it, right? So again, to keep the video short enough, I'm going to go ahead and handle that on the calculator. So I'm going to plug in the value of -1 into the left side of the equation, and I get let me go ahead and type in a fraction. I want to make sure we get rid of the answer. Okay, so 3 times -1. When it's easy, I'll just do it in my head. So that's going to be -3. Now remember, on a calculator like the HP Prime, you don't want to use this. You want to make a distinction between a sign and an operation. So if you want to type in -3, you have to put that and then 3. And then plus 2, remember I already plugged in the -3, so down below we have what? We have -1 minus 2. Now we move on and we get plus. We have another fraction. On the top we have 1, on the bottom we have -1. Remember, again, we have to use that negative symbol. So they make a distinction between a negative and a minus. All right, so now go ahead and hit enter because we plugged in everything into the left side. Now we'll do the same thing on the right side, right? So we get what? So we get negative. Well, let me be consistent. I'm going to hit this first. Well, in this case, it's probably better just to type in the -2. That way I don't have to go get rid of that A and S, right? That just means the answer from the previous step. Okay, and I get that. Now I get what? -1 squared. What's the square of -1? I should say quantity -1 squared. Because otherwise you don't want to make, you want to make sure you're not just squaring the 1, you're squaring the negative as well. So quantity -1 squared is 1. So I get 1 minus 2 times, I'm going to plug in the -1. All right, so now we're ready to hit enter. What do I hope to see once I hit enter if I've done this correctly? I hope to see that answer, right? Because that's what it should be. And in fact, I get what? I get the opposite of that answer. So that one did not work either. Let's make sure that we plugged everything in correctly. -2 over 1 minus 2 times -1. Yes, sure enough, okay? All right, these are kind of close. I'm starting to wonder if I should double check. Let's do that. this could be a good learning moment for us, because you may run into a situation like this as well. All right, so let's see. So here we had 3 times -1, which is -3 plus 2. Oh my God, there it is. Now, here's a nice thing about this calculator. I'm not going to have to type all that in again. So I'm just going to fix it. So I'm just going to come over here, and I'm going to change that minus that I had written incorrectly to a plus. And let's make sure that we did the rest okay. So on the bottom we have x, which is -1 minus 2, and then plus 1 over -1. Okay, let's try that now. And guess what? We were okay. All right, so I had mistyped -2, whereas I should have had a what? +2. Okay, so, and this is, you know what? I could have redone this video and everything to appear perfect, but I would rather that you see that we're all humans and we make mistakes. So as long as you're careful and you double check, you should catch your mistakes by the end. But notice that that's a very easy mistake to make. So now the problem is I didn't do something that I usually do, which is as soon as I type something from one medium to another, and I said this before on this video, I didn't double check. So let's make sure that we do that from this point forward, okay? So there it is. So it does work, and it is a solution. So even though 0 needs to be excluded because it is one of the restricted values of x, -1 does tend to create the same outcome on the left and the right side, so it does make the equation true, so it is a solution. So now we'll just write our solution set to be the set containing -1. All right, so there it is. All right, so make sure that you can handle a simple problem like that, and we'll proceed. Again, the trick is if you don't get a problem correctly the first time, then just keep doing it until you do get it correctly, and that process is extremely helpful in you realizing the things that maybe you're not doing correctly to get to the proper answer, and then a self-correction kind of mechanism starts to kick in, okay? And you'll be less likely to make those kinds of mistakes again later. All right, so go ahead and make sure you can do this. We'll move on. All right, now we'd like to take a look at a group of problems known as work problems. This is basically when different entities are working at their own individual rates on the same problem, okay? Trying to accomplish the same or finish the same job. And these types of rate problems are known as work problems. All right, so the formula we need to understand to be able to solve work problems is as follows: rate times time equals jobs. Symbolically, we just put R times T equals J, right? And if there's more than one individual, sometimes we'll use subscripts like R1, T1, etc. So if a person does one job in T hours, then that person's rate can be found by substituting 1 for the J, the number of jobs, T for time, and solving for R. So we get R equals 1 over T jobs per hour. So usually the T is known, so it will work out for us once you see some examples. All right, let's have a look at this problem. We have one printer that can do a job twice as fast as another. So we basically have a slow printer and a fast printer. Working together, both printers can do the job in 2 hours. How long would it take each printer working alone to do the job? This is a classic kind of work problem that we can tackle. Now, when it comes to organizing your information, remember that we had a 3-step plan for solving word problems. The first one is to understand the problem, and in that phase, you want to use any kind of tool available to you: sketches, tables, etc. And among them, table is one of the most useful. So we can set up a table to organize our information. Then we're going to translate. Once we've understood the problem, we're going to translate it from English to mathematics, and then we're going to go ahead and proceed with solving it. Okay, so the three steps again: understand, translate, and solve. So usually they give you more steps. I've tried to make this as simple as possible so you can remember it. And solve. So as simple as 1, 2, 3, right? So in order to understand it, I'm going to go ahead and utilize a table. I know the formula I need to use. Remember from the previous screen, rate times time equals jobs. So that's how I'm going to create my table. My headings are going to be rate, time, and jobs. Now, in the header of each column, I'm going to put the units so that I don't have to keep writing it in each entry. So here we know the rate we're dealing with is jobs per hour, right? Time here is going to be in hours, and jobs, they're just going to be, the unit is just going to be jobs, right? Okay, so remember we have a slow printer and a fast printer. Usually when they say one printer can do a job twice as fast as another, look at a phrase similar to as fast as, or triple the speed, or whatever, and whatever comes after that is what you're going to want to name first, right? So let's say the fast printer can do a job twice as fast as the slow printer, right? So the slow printer is the last name that's mentioned in that phrase, or that sentence, in fact. So we'll go ahead and give that a name. So let's just call that X, okay? So we don't know the rate at which the slow printer works, but if we call it X, we know there's a relationship between that speed and the speed of the fast printer, right? The faster printer is twice as fast. Now remember, these are rates we're dealing with, not times. Now we know that they're both working for 2 hours. In other words, you turn them on at the same time and let them run for 2 hours. So each is doing its own work at its own speed. Remember, that's a classic work problem. But they're working on the same job, right? So working for 2 hours, right? And so the total amount of the job done by the slow printer is going to be the product of these two, so 2x. And for the fast printer is going to be 2 times 2x, which is what? 4x. Now, if you want to add a totals column, you can, but keep in mind, a totals column will only, row, sorry, not column, row. Yeah, the total row will only have entries in certain places where it makes sense, right? There is no total rate. There's no, well, total time in this case wouldn't make sense because they're not going to be working separately at that rate, right? They're doing a total of 2 hours, 2 hours, not 4 hours for either one. So, but the total for the job we do know. We want this to total one job, right? So this right here, this column with all the pieces existing is going to help us to be what helps us solve this problem. So basically we know that 2x, the amount of the job done by the slow printer, plus 4x, which is the amount of the job that's done by the fast printer. That's an X there, even though it doesn't look quite like it, is going to equal to one whole job, right? So we get 6x equals 1, so x equals 1/6. Now remember what the rate units were? Jobs per hour. So we can just say J over hour, right? Jobs per hour. Now, they didn't ask us for that, did they? They didn't say, hey, what's the speed or what's the rate of each printer? They said, how long would it take each printer working alone to do the job, right? So what we can do now is we can first go ahead and figure out the rate for the fast printer, right? So this means, so this is the rate for the slow printer, which means the rate for the fast printer is going to be twice that, right? Which is 1/3, right? Job per hour. Now, you could go further and do other equations, etc., but it's really not necessary, is it? Because this is a simple, we know that you can see from the rate, this printer does one job in 6 hours, right? So what is the amount of time that it would take the slow printer to do the job by itself? Right there, 6 hours. So what I was talking about is you could set up two equations like this: rate for the slow printer, time for the slow printer equals 1, and then rate for the fast printer times time for the fast printer equals 1. Solve each of these to get the rate for each individual machine, right? Now we know the rate for the slow printer is 1/6 times the time for the slow printer equals 1. Cross multiply. Let's say that's 1/1, so you get TS equals 6. So there is the time for the slow machine if you want to use an equation to get it. For the fast machine, we know the rate for the fast machine is 1/3. And we want to know what the time for the fast machine is to do one job, right? So again, cross multiply, and you end up with the time for the fast machine is 3 hours. Okay, so again, you could have known this information by just looking at the rate, right? One job in 6 hours. Or you could also show it like this as two separate equations for each equation. All right, so make sure you understand that before we proceed. All right, next we want to take a look at the power property, which is going to help us solve equations involving radical expressions. So that's the next thing we want to take a look at. Now, the principle that's going to help us solve radical equations is the fact that if P and Q are algebraic expressions, then every solution of the equation P equals Q is also a solution of the equation P to the n equals to Q to the n for any positive integer n. Now, be extremely careful because this is a one-way conditional. In other words, it doesn't work the other way around. Just because a solution works for a power, it doesn't mean it will work for the bases as well. So the power expressions as opposed to the base expressions. Here's a quick equation to take a look at. Now we know that, for example, x squared equals 4 has two solutions, namely x equals positive or negative 2, right? But if I'm looking at just one scenario, say for example x equals 2, right? Notice that a solution of x squared equals 4 is also x equals negative 2, which is not a solution of that simple equation there. So be careful not to take this statement in the other direction. All right, so now the way this is going to help us is basically when we get an equation containing radicals, we're going to use these 4 steps. We're going to isolate the radical on one side of the equation, and then we're going to raise both sides of the equation to a power that is the same as the index of the radical so that the radical becomes eliminated on that side. And at times, even after you do that, there's still some radical expressions left. So if that's the case, you're just going to repeat steps 1 and 2. until you have no longer any radicals existing, and then you're going to solve the resulting equations, and you're always going to check to make sure, because remember, once you raise to a power, you're solving a modified equation. You want to make sure that the solution also works for the original equation, the solution that appears to work for the modified equation, okay? And any solution that works for the modified equation but not for the original equation is what we call an extraneous solution or an extraneous root. All right, so here's an equation we're going to solve. Notice that what we're going to do is we're going to isolate this radical expression by moving it to the other side. Remember, change sides, change signs, right? So the negative is going to become positive on the other side. Why? Because we're basically adding this expression to both sides. So we get x equals square root of 15 minus 2x, right? Now we're ready to go ahead and proceed by with squaring both sides. So we get x squared equals, now when we know that if we square a radical, we're just going to get the radicand, right? The square root of any number squared is just the number itself, right? So we get x squared equals 15 minus 2x. Now we're going to go ahead and realize that this is not a linear equation, it's quadratic. It's a higher order equation, so we need to move everything to the left side and see if we can factor. So we move the negative 2x, it becomes positive 2x. We move the 15 to the left side, becomes negative 15. And of course, we're just adding 2x and subtracting 15 from both sides. All right, at the same time. All right, so now we go ahead and realize we have a simple quadratic. We're looking for two numbers whose product is negative 15 and whose sum is positive 2. Now, thinking of the factors of 15, I think you realize that we're going to be looking at negative 3 and positive 5, right? Notice their product is negative 15 and their sum is positive 2, right? So we get x minus 3 times x plus 5 equals 0. Now we apply the zero factor property. So we get either x minus 3 equals 0 or x plus 5 equals 0. So this gives us x equals 3 or x equals negative 5, okay? Now at this point, it's extremely important, particularly when the index is even, that you check your solutions, make sure they both work. So we're going to check x equals 3 as a solution. That means we're going to plug it in. So we want to know if 3 minus square root of 15 minus 2 times 3 is equal to 0. Now I'm going to put a question mark above the equal sign because I'm not asserting that, I'm checking that. So we get 3 minus square root of, now 15 minus 6, that's 9. And we want to know if that equals 0. Notice I still need the question mark because I haven't reached an identity yet. Now that's 3 minus 3. I want to know if that's 0. Finally, I reached my identity. 0 equals 0. At this point, I can drop the question mark because I'm no longer check it. I have now verified it. Okay, so that means x equals 3 checks out. It is a solution. I'm going to go ahead and erase this stuff over here so I can check the other potential solution, negative 5. So now we're checking x equals negative 5. So we have negative 5 minus square root of 15 minus 2 times negative 5. We want to know if that's equal to 0. So we have negative 5 minus, now inside we get 15 plus 10, which is 25. So square root of 25, we want to know if that's 0. That's negative 5 minus 5. We want to know if that's equal to 0. But I notice here I get negative 10, and on this side I get 0. And so that we know is not true. So we've reached a contradiction. That means what? That means that is not a solution. So the only solution that ended up working was the 3. So when we write the solution set, we're only going to put the 3 inside our solution set. All right, so make sure that you're comfortable with that, and we'll proceed. All right, here's another equation we're going to look at now. Remember, the instructions said try to get your radical on one side, but when you have two of them, that's pretty much going to be impossible, right? So we'll do the next best thing, which is try to have at least no more than one radical on each side. So let's go ahead and move this one to the other side. And it's a negative term, so when it moves to the other side, it becomes positive. So we get, now I do know that once we get to each problem, you're pausing the video and then trying it on your own first, right? Because if you haven't, you really should. Especially if it feels like you should be able to do it, right? Because that's when you're doing yourself a big favor. All right, so now I'm going to go ahead and square both sides. Now, this problem is not difficult, but this side gets a lot of people in trouble because they still have not completely solidified this concept in their head that the square of x plus y is not the sum of the squares, okay? Remember, if you have x plus y squared, that's x squared plus 2xy plus y squared. So as long as you remember not to do this, you'll get this problem correctly. So so on the left side, I get 2x plus 3. Now, if you don't know the formulas and all that, and you want to make sure you get this right, just write it out. Just write it out as square root of x plus 1 times square root of x plus 1 plus 1. So now we're going to go ahead and multiply it out. So we get 2x plus 3 is equal to, now square root of x plus 1 times square root of x plus 1, that's just going to be the square of the square root of x plus 1, which is just x plus 1, plus square root of x plus 1 times 1, that's just going to be square root of x plus 1. Now we're going to distribute the 1. We distributed the square root of x plus 1. Now we're going to distribute the 1. So we get plus 1 times square root of x plus 1, which is just another square root of x plus 1. And then plus 1 times 1, right, which is 1. All right, lots of 1s there, right? So we get 2x plus 3 equals, all right, so we get x. There's nothing I can combine it with. There are 2 of these square root of x plus 1s that I can combine to get 2 square root of x plus 1. And don't forget that I can go ahead and combine this 1 and this 1 over here. So we get plus 2. All right, so notice there is nothing I can do on the left side as far as simplification is concerned, and nothing I can do on the right side as far as simplification is concerned. So I'm going to go ahead and isolate this radical once again. Remember, if you still have a radical left, you just continue with the same process you just used. So this time I'm going to leave it on the right side, and I'm going to move these two guys to the left side. And remember, they're both going to change signs. So I get 2x plus 3 minus x minus 2. So now 2x minus x is x, and then I get plus 1 equals 2 radical x plus 1. All right, so again, we're ready to go ahead and square both sides. We've simplified, so we'll go ahead and do that. So on the left side, I have x plus 1 times x plus 1. On the right side, the 2 squared is going to give me 4, and the square root of x plus 1, quantity square root of x plus 1 squared is just going to give me x plus 1. So on the left side, we go ahead and distribute the x, then we distribute the 1. Okay, so when you distribute the x, you get x squared plus x. When you distribute the 1, you get x plus 1. So we have x squared plus 2x plus 1 equals 4x plus 4, right? There's no more simplification possible on either side, so we go ahead and move everything to the left side. So x squared plus 2x plus 1, 4x becomes negative 4x. When it moves to the left side, 4 becomes negative 4. So now we combine like terms, so we have x squared minus 2x minus 3 is equal to 0. Now we go ahead and factor. So we get x. Remember, you're looking for two numbers whose product is negative 3 and whose sum is negative 2. And I think it's pretty obvious that's going to be negative 3 and positive 1, right? Notice their product, when you multiply them, you get negative 3. When you add them, you get what? Negative 2. So we have minus 3 and plus 1. Now we apply the zero factor property, which says either x minus 3 has to be 0 or x plus 1 has to be 0 if their product is 0. In other words, you can't multiply two non-zero expressions and get 0, right? If you multiply two expressions and you get 0, one of them has to be 0. One or both, right? It's okay if they're both 0 as well. All right, so we get x equals 3 or x equals negative 1. So let's go ahead and check x equals 3. So we get square root of 2 times 3, which is 6. Plus 3 minus the square root of 3 plus 1, which is 4. And we want to know if that is equal to 1. Now that's the square root of 9, which is 3. And that's the square root of 4, which is 2. We want to know if 3 minus 2 equals 1. Yes, 1 is indeed equal to 1. This one checked out. Now we'll do the same for negative 1. So square root of negative 1 times 2 is negative 2 plus 3. Minus the square root of negative 1 plus 1. We want to know if that's equal to 1. So now this here is negative 2 plus 3, that's 1. The square root of 1 is 1. And this is negative 1 plus 1 is 0. Square root of 0 is 0. We want to know if 1 minus 0 equals 1. And of course 1 minus 0 is 1, which is equal to 1. Notice once we get to an identity or to a contradiction, we can drop the question mark. So at this point, we say yes, and it checks out. So both of them work. So we have two solutions. So for the solution set, we're going to put both of the numbers. So one of them was 3, the other one was negative 1. Now, remember, solution sets are not ordered. In other words, sets are not ordered. In other words, if I write 3 comma negative 1, and you come up to me and say, hey, that's not right, you should have put negative 1 comma 3, I'll say, hey, let's agree to disagree on that, but the point is that they're both correct. These two sets are indistinguishable. They're identical as far as sets are concerned. They're the same set. So you can write it in either way. All right. So that's that. Make sure this one, was quite a few steps. Not difficult, but you have to just be careful. All right. So make sure you can carry a process like that on your own by just doing this, or you can always find extra questions like this either on the internet or on your homework sets, and give it a try. Okay, and that's it. And or sometimes you can even create your own problems if you really want to have fun. Okay, so let's go ahead and move on. All right, so here's the one with involving cube roots, and it's not handled any differently. Now here we only have 2 cube roots, so let's go ahead and get one on each side. So the cube root of 4x squared minus 4x plus 1. Now I'm going to move this one to the other side so it becomes positive, so I just get cube root of x. Now we go ahead and cube both sides. And we keep in mind that if we take the nth root of any number and raise it to the power of n, that just gives us the number itself, right? So the cube root of all that cube just becomes 4x squared minus 4x plus 1. And the cube root of x raised to the power of 3 will just give us x. Now all we have to do is solve this quadratic by moving the x to the other side. So 4x squared minus 4x plus 1 minus x equals 0. So 4x squared minus 5x plus 1 equals 0. And we go ahead and try to factor that. Now, do not use this little cross trick that we've been using. The cross trick only works if the lead coefficient, which is the coefficient of the x squared, is 1. Okay, so make sure you do not use that trick when this lead coefficient is not 1. So we won't use that. We'll go ahead and just do trial and error. Okay, so we can do 2, 2, or let me just try 4x and x. Now 1 is easy. It has to be 1 and 1, right? So notice that the inner product is x. The outer product is 4x. Notice how I'm not putting any signs. I encourage you not to do that either. We're going to put the signs when it matters. Now, what do I want the inner product and the outer product to add up to? To the middle term, right? So we want negative 5x. The question is, can we get negative 5x from these two guys? Yeah, we can if they're both what? If they're both negative. So there it is. There's your factorization. Remember, first term times the first term should give you the first term. Last term here times the last term here should give you the last term, which it does, right? They do. And the inner product, which is negative 1 times x, and the outer product, which is negative 4x, they should add up to the middle term. As long as you've checked those 3 things, you know you factored it correctly. So now we're going to apply the zero factor property. So we get 4x minus 1 equals 0, or x minus 1 equals 0. So 4x equals 1, or x equals 1/4. And this one gives me x equals 1. Okay, so I'm going to leave it for you to plug this in and make sure that they work out. It's a great practice for you to do. And as you will see, they both work. So we can say the solution set equals the set containing 1/4 and 1. All right, so that's how you handle that one. All right, here's one that's not quite given as a radical, but if you remember, there is a relationship. This is really a radical equation because if you remember, we have this x to the m over n rule, which is the nth root of x to the m or the nth root of x to the m. These two expressions are equivalent and they're both equal to that, so they're all really equivalent and they give the same output. So now here we could translate that into radical form and then proceed, or we could just handle it as it is. So what we'll do is we'll say, look, we're trying to raise both sides to a given power, right? What power does that have to be? Well, I want to get x to the power of 1, and I know the power rule tells me that if I have x to the m to the n, I need to multiply those two exponents, right? So I want 3/5 times some number to equal to 1, and we know that that's very easy. That just has to be the what? The reciprocal, right? Or the multiplicative inverse. So what we're going to do is we're going to raise both sides to the power of 5/3. Now on the left side, I just get x, right? Because remember, we got to multiply these, and 3/5 times 5/3, that's 1. And x to the 1 is just x, right? On the right side, I get this. Now, it's easier for me to translate that into a radical in order to evaluate it. So remember, when you go to radical mode, the denominator becomes the index, the base becomes the radicand. Now the power can go as a power of the radicand either inside or outside. It's much easier if you actually put it on the outside, because who wants to sit there and figure out 27 to the power of 5 when they don't have to? See, I mean, you could do it that way, but it's not. It's going to be a much larger number you're going to have to deal with unnecessarily. It's much easier if you take the cube root of 27 first, which gives you 3, and then raise it to the power of 5. And that, of course, is, let's see, 3 to the 4 is 81. 81 times another 3 gives you 243. Okay, so that is going to be our x value. So all you need to check is now if this is going to give you a true statement, right? Let's try that. So we want to know if 243 to the power of 3/5 is equal to 27, right? Well, remember, we're going to turn that into a radical, so that means the 5th root of 243 cubed, we want to know if that's equal to 27. Now, what is the 5th root of 243? Well, if you remember, we just raised 3 to the power of 5 and we got 243. So what is the 5th root of 243? What is the number that you have to raise to the power of 5 to get 243? Well, it's obviously 3. So we get 3 to the power of 3, and we're trying to see if that's equal to 27. And 3 cubed, of course, is 27. So we get 27 equals 27. We have verified. We can drop the question mark and put a check. So it worked. So basically, the solution set is going to contain one solution, and that's 243. All right, so simple one. We'll go ahead and look at some other concepts now. All right, on this next one, I want you to be really careful. In fact, I need you to be really careful whenever this numerator here is even, because if you were to do a similar thing to what we did in the other case where that was odd, here's what the problem you'll run into. Let's say, so in other words, here's what I don't want you to do. I don't want you to say, okay, I'm going to take this and raise it to the power of 3/2, and that should equal to 16 to the 3/2. So x minus 4 equals, that's the square root of 16 and then cubed, right? So x minus 4 equals, the square root of 16 is 4 cubed is 64. So I get x equals 64 plus 4, which is 68. Now, as you're going to find, it's very easy to see that 68 actually will work as a solution. 68 minus 4 is 64. The cube root of 64 is 4 squared, gives you 16. However, the problem is you will lose a solution if you do it this way. Okay, so here's the proper way of approaching this. When you see an even number on the top there, you should go ahead and turn it into a radical equation first. That's the safest thing to do. So here we're dealing with the cube root of x minus 4 squared equals 16. Nothing changes about 16. We're not doing anything except changing forms here, right? Now this is where you have to be careful, because here, you know, we have the square root property, which says x squared equals k if and only if x equals what? Plus or minus the square root of k, right? So this is where you're going to treat all of that as simply just x, right? You can treat, that's what's playing the role of x here, all of that. So we apply the square root property, and we say the cube root of x minus 4 equals plus or minus square root of 16. Okay, so the cube root of x minus 4 equals plus or minus 4. So that's really two equations that we need to consider. One is the cube root of x minus 4 equals 4. The other one is the cube root of x minus 4 equals negative 4. Now, if this were a square root, we would have no real solution, but it's a cube root, so no problem. A cube root can be negative. So now we go ahead and cube both sides of each equation. So we end up with x minus 4 equals 64, which gives me x equals 64 plus 4, which is 68. We saw that before, but now we also get this other solution which we missed last time. So we get x minus 4 equals negative 64. So x is negative 64 plus 4. So x equals negative 60. So we actually end up with two solutions. Now, I already showed you how to check 68. Negative 60 will work too, because look, we get negative 60 minus 4 to the power of 2/3. We want to know if that's equal to 16. So we have negative 64 to the power of 2/3. We want to know if that's equal to 16. So that's the cube root of negative 64 and then squared. We want to know if that's equal to 16. Cube root of negative 64 is negative 4, but when you square that, you do in fact get 16 equals 16. So this checks out as well. So remember, we have two solutions, namely negative 60 and 68. They both work. Okay? All right, so a good problem, you know, and has a subtle point that you need to pay attention to. If that numerator is odd, we don't run into this issue. But when it's even, you run into this kind of issue that you have to be careful about. Notice that when we did it before, we didn't run into any issues because that was an odd numerator there. I just wanted to show you quickly. All right, the last topic we're going to look at today is equations quadratic in form. Basically, any equation that can be put into this form is said to be quadratic in form, because u doesn't have to just be a simple letter u. It could be any expression, okay? U can be any algebraic expression, and as long as we have that, we basically have an equation in quadratic form. So why do we not want a to be 0? Because remember, if a is 0, it's no longer quadratic. This term collapses, you go down to a linear equation. So that's why we want to specify that a should not be 0. All right, so let's go ahead and take a look at this problem, right? Now, a lot of times, it's really a good idea to go ahead and specify what your u is, meaning what is the expression that you're going to use for the letter u in order to do a substitution. Now, in this case, I notice that I have x to the 2/3, which is, notice, that's just the square of this term, isn't it? Right? When you square quantity x plus 1 to the 1/3, you get quantity x plus 1 to the 2/3, right? So that's what we're going to let u be. We're going to let u be this expression here. So let u equal x plus 1, quantity x plus 1 to the power 1/3. So now we're going to replace each of these two expressions with a u expression. Now remember that when u is that, this implies u squared is going to be x plus 1 to the 1/3, and then the whole thing squared, which is just basically x plus 1, quantity x plus 1 to the 2/3, right? So instead of this expression, the first term, we're going to write u squared, because remember, if u is the quantity x plus 1 to the power 1/3, then u squared becomes quantity x plus 1 to the 2/3. So we have u squared minus, now this expression here is just what we call u, right? So minus u minus 2 equals 0, right? All right, so notice that that's a simple quadratic that we can factor. We're looking for two numbers whose product is -2, sum is -1. There's a negative invisible 1 there, right? Now, we can use this because the lead coefficient is 1. We can use our cross trick, right? Notice, in order for that to happen, the numbers would have to be -2 and +1, right? Their product is -2. Their sum is -1. So we have u minus 2, quantity u minus 2 times quantity u plus 1 equals 0. Now we apply the 0 factor property. So we get u minus 2 equals 0, or u plus 1 equals 0. So either u equals 2 or u equals -1. Now, most of the students who miss this problem are the ones who rush and just put these as the solutions. Remember, this problem is not asking you to solve for u. It's asking you to solve for x. So once you have the values for u, you have to go back in and plug the quantity x plus 1 to the 1/3 for u. Okay, so we get quantity x plus 1 to the 1/3 equals 2. Remember, that's just because u is equal to quantity x plus 1 to the 1/3, or quantity x plus 1 to the 1/3 equals -1. So at this point, all we have to do is go ahead and cube both sides of both of these equations. So on the first equation, we get x plus 1 equals 8, or x equals 8 minus 1, which is 7. In this one, we get x plus 1 equals -1, so x equals -1 minus 1, or x equals -2. All right, this video is getting up there in length, so I'm going to go ahead and leave the checks for you, but I will tell you this, they both will work. So make sure you take the time to do the check. Great practice for you. And you get the solution set is the set containing both of those. So -2 and 7. All right. So there's a good problem with u substitution. All right, here's another problem which is quadratic in form. Let's go ahead and move everything to one side first. That way you can see the quadratic nature better. So we have 6x to the negative 2 plus x to the negative 1 minus 2 equals 0. Now, the thing to notice is that if you take x to the negative 1 and square it, you get what? You get x to the negative 2. So we do have an expression and the square of that expression and then a constant. So we are quadratic in form. So we're going to let u equal x to the negative 1. Once you know that, you should be able to take this all the way to the finish line. So if you haven't paused yet, please do and try that. All right, so we have, if u equals x to the negative 1, remember this implies u squared is the square of x to the negative 1, which is x to the negative 2. So now we're ready to substitute. So instead of 6x to the negative 2, we're just going to put 6u squared plus, instead of x to the negative 1, we're just going to put u, and then minus 2 equals 0. Once you do the substitution, you clearly see how the equation was quadratic in form, you see? So now, again, we can't use the cross trick because the lead coefficient is not 1, nor can we divide it off to make it 1. So sometimes it's not 1, but you can divide it off and you get 1. But here we can't. So we go ahead and do trial and error, or the FOIL method, right? Same thing. So let's try maybe 3u and 2u. And remember, you get better and better with this as time goes on. How about a 2 here and a 1 here? Will that work? Let's see. The inner, notice no signs yet, but I'll know the inner product is 4u. The outer product is this product, which is 3u. And what do I want? I want them to combine to give me the positive u in the middle. So this is the first place I introduce a sign. Can I get positive 1 from 4 and 3? Well, I can if the 4 is positive and if the 3 is negative, right? So the plus will go here and the minus will go here. Now we'll check it anyway. So first times first should give you first, does it? Yes, it does. 3u times 2u is 6u squared. Last term times last term, positive 2 times negative 1. Is it negative 2, which is the last term? Yes, it is. So the inner product, which is positive 4u, and the outer product, negative 3u, they add to the middle term. We knew that already because we forced it that way. So the factorization is correct. So now we apply the zero factor property. So we get either 3u plus 2 equals 0 or 2u minus 1 equals 0. So 3u equals negative 2 or u equals negative 2/3. And 2u equals 1 or u equals 1/2. Remember, we are not done. Those are u values. We now need to go get the x values. Now we just need to substitute what u is. And remember, u is x to the negative 1. So x to the negative 1 equals negative 2/3, or x to the negative 1 equals 1/2. Now, the way you go about this, is, up to you, what you're comfortable with. One thing you can do is just take the x to the negative 1, write it as 1 over x, and write the right side as negative 2/3. This is nice because then you can just quickly handle it as a proportion and then cross multiply. So cross multiplying gives us negative 2x equals 3 So x equals -3/2. Cross multiplying over here will give us x equals 2. All right, once again, I'm going to leave the checking to you, and I will let you know that they both work once again. So make sure that you plug those in and verify that both of these are indeed solutions. All right, so the solution set is going to be the set containing -3 and 2. All right, so nice simple problem, but you just have to get comfortable with the procedure of U substitution. Then it becomes really easy. All right, so here again, we want to see if we are in this format. In other words, we want to have some middle expression and then the square of it in the first term, right? Of course, that's if they're written in descending order, right? Notice that, yeah, we have x squared, and if I square x squared, I get x to the 4. That tells me, and then a constant, right? That tells me I am in quadratic form. Okay, so what would you let u be here? I think you know by now we're going to let it be x squared, which implies u squared will be the square of x squared, or what? What's the square of x squared? X to the 4, right? So instead of writing 12x to the 4, I'm just going to write 12u squared. Remember, u squared is x to the 4, right? So we get 12u squared minus 11u plus 2 equals 0. So now we're going to go ahead and just factor that, and we can't use the cross trick because the lead coefficient is not 1. So we'll use the trial and error FOIL method, right? So why don't we try 4u and 3u, and maybe we'll try 2 and 1. Again, you get better at this the more you practice, right? So the inner product is 3u, the outer product is 8u. We want their combination to be -11u. Can you somehow get -11u from these guys? Yeah, you can if they're both what? Negative. So negative all around. And we quickly check. First times first is first. Last times last is last. Inner and outer products add up to the middle term. So we factored it correctly. So again, we're going to say by the zero factor property, either 4u minus 1 equals 0 or 3u minus 2 equals 0. So 4u is equal to 1, or u equals 1/4, and 3u equals 2, or u equals 2/3. Now, do not stop because you're not finished. These are u values. We need x values. Now we have to substitute what u is, and you know that the value of u is x squared, right? So x squared, not the value, but the expression for u. So x squared equals 1/4, or x squared equals 2/3, right? So this gives us x. Now we're going to apply the what? The square root property. Remember? X squared equals k if and only if x equals plus or minus square root of k. We call this the square root property. All right, so that means x equals plus or minus square root of 1/4. This one gives us x equals plus or minus square root of 2/3. Now this one is easy. That's just plus or minus 1/2, right? This one you got to do a little bit of work with. So it's plus or minus square root of 2 over square root of 3. And we'll go ahead and rationalize the denominator by multiplying top and bottom by the square root of 3. So we get x equals plus or minus square root of 6 over 3. Now, notice that you actually have how many solutions? Think about it for a second. How many solutions do we have here? Now, I will let you know they all work. So I do want you to at least check them in a calculator, but do verify them, and they will all work. And that makes 4 solutions. Plus or minus 1/2. 1/2 is a solution. Negative 1/2 is a solution. Same over here, right? So to write the solution set, we're just going to say negative 1/2, 1/2, and square root of 6/3, and negative square root of 6/3. Now, sometimes homework systems like my math lab will let you use this plus or minus notation. But I always want you to be aware that when you're looking at that, you are looking at 2 solutions. So 2 and 2 makes 4. Here we wrote it out completely. So of course all systems will accept the, spread out format as well. All right, so that's that. And the last thing we want to do is I want to do this same problem again with you, but without substitution, because sometimes it's a little quicker to do it that way, right? So let's try that. All right, here's our last problem for the day. We're going to factor this just directly, okay, without going to a use substitution. So remember, we're just going to factor right away. We're looking for 2 expressions whose product is going to give us 12x to the 4. So the numbers are going to be very similar to what we used before. I think we used 4 and 3, right? So 4x squared and 3x squared. Notice when you multiply those two, what do you get? You get 12x to the 4, right? And then remember we used 2 and 1, and they both had to be negative, right? So let's double check. First times first gives us first. Last times last gives us last. Inner and outer add up to the middle. So we get 4. We're going to go ahead and apply the zero factor property right away. So the zero factor property says either 4x squared minus 1 equals 0 or 3x squared minus 2 equals 0. So 4x squared equals 1, x squared equals 1/4. The rest should look familiar, right? So x equals plus or minus square root of 1/4. So x equals plus or minus 1/2. Same thing over here. 3x squared equals 2. So x squared equals 2/3. So x equals what? Plus or minus square root of 2/3. Again, x equals plus or minus square root of 2 over square root of 3. Rationalize the denominator. So we get x equals plus or minus square root of 6 over 3. Of course, we have the same solutions. So our solution set, let me write it in compact form this time. Just like that, okay? So obviously, if you don't have to use substitution, you can opt out of it. Sometimes substitute, remember, if you're familiar enough with these concepts, you can almost always bypass substitution. But if you get confused with some of the direct actions, then always use substitutions to make it easier for yourself. All right, so that should do it, and we should be good to go until next time. So take care of yourself until the next video.